June 2014, M2 paper, Edexcel. We're just going to do the first 4 questions, I think, in this video, and then leave the final 4 questions to the part 2. First part, nice and easy. It's basically a load of particles in a coordinate axes. Don't see this very often. When you do, you kind of realise that you've got easy marks to gain really here. I like to put these things in a table. Those are the separate masses. Obviously those connected together will be 5m plus km, 5m plus km, so that's 5 plus k. M will be the three masses added together to have the composite. So these are the separate ones. Now what does it tell us? It gives us the coordinates of all of the points except the km one. The 3m, that's the x and y coordinate. The 3m1 is placed at 1, 5. The 2m1 is at 6, 4. The km1 is at some a, value of a1. And we know the composite mass has a centre of mass at 3, 3. Now, I'm going to the first bit is to work out k. If I take moments for the a bit now, I'm going to have 2 unknowns. So if I use sigma mi xi or yi equals to y bar sigma mi. In other words, this times this plus this times this plus this times this equals this times this. And then that will work out k straight away. And when I know k, I'll be able to work out a for part b. So that's 3m times 5 equals to 2 plus 2m times 4 plus km times 1 is equal to 5 plus k m times 3. Okay, and the m cancels. So multiplying this out, I get 15, 8 plus k equals to 15 plus 3k. So that gives me 2k equals 8, which gives me k equals 4. Okay, and then now I know k is 4. I know I know that this is 4m here, and I know that this is 9m here. So I can use the take moments again. So use sigma mi xi is equal to x bar sigma mi. So again, this times this plus this times this plus this times this equals this times this. Okay, so we have 3m times 1 plus 2m times 4 plus, now that's 4m times 1 because we now know that k is 4 equals 9m times 3. Obviously k cancels once again, and so I just need to multiply out and work out what, or my a has somehow gone astray, and have I chosen the wrong numbers? That wasn't particularly, I went to the wrong numbers here. That doesn't look right, does it? Okay, it's correct. 3m times 1, it just shows you again, take care, I didn't even have an a in my equation. You know, at least then I knew that I couldn't possibly be right, I suppose. But anyway, this is the correct equation. And m cancels again. So I have 3 plus 12 plus 4a equals 27. So that gives me 4a equals to, taking the 15 over, equals to 12. So a equals 3. Right, 5 minutes for 6 marks, but I did make a mistake, so yeah. Pretty easy, I think. So let's see what question 2 has in store. This is motion in 2D, where acceleration is a function of time, variable acceleration. Right, tells us a bit of information. It gives us what's called a boundary condition sometimes, t is equal to 3 at that point, and it gives us an expression for a in general. Let's write that down. We've got a is 3t squared minus 4t I plus 6t minus 5j. Now we can integrate that to get the velocity. Velocity is equal to integral a dt. So that equals this bit integrated, 3t squared is t cubed. 4t is 2t squared I plus 6t integrated is 3t squared, and 5 integrated is 5t j. Now I tend to write my constant like this. You can write it in other ways, but I like to do that to emphasize it. Obviously there's a constant, which is a constant, and our constant overall is a vector, so c1i plus c2j, or ai plus bj if you want to, whichever way you want to write it. Now we're told when t equals 3, v equals to 11i plus 10j. So that means 11i plus 10j equals 3 cubed minus 2 times 3 squared plus 3 times 3 squared minus 5 times 3 j. Oh, we've forgotten to write my I there. J plus c1i plus c2j. Okay, so we need to work these out. So let's not rush this too much. 11i plus 10j. This here is 27, take away 2 times 9, so that's 9i. This here is 27 minus 15, so that's 12j, plus c1i plus c2j. Okay, so that gives us that c1i plus c2j equals 2i minus 2j. Okay, so obviously c1 equals 2 and c2 equals minus 2. Right, so now I'm going to put the velocity, because we worked out velocity here, I'm going to put velocity back, put my values of c1 and c2 back in, but instead of writing it at the end here, I'm going to incorporate my I into the I component. Hopefully you'll see what I mean when I've written it. 2 cubed minus 2t squared plus that c1, that value of c1, which is 2i, plus, and then it's 3t squared minus 5t plus that value of c2, which is minus 2j. And that's our 5 marks for the velocity. Right, now that's that thing. Then so we've got that velocity now. Then it says find the speed when it is moving parallel to I. Parallel to I means that means there's no j component parallel to I, but if we look at this, it just means it's going in one direction, no j component. So that must mean 3t squared minus 5t minus 2 equals to 0. That factorizes, I believe, into this. 3t plus 1 t minus 2 equals 0. Obviously the negative one's not appropriate, so we're not going to consider that one, so we have t equals 2. Right, so if we put t equals to 2 back into v, we get v equals to, now obviously we don't need to put it back here because we know that's 0, so we're just putting 2 into here. So v equals 2 cubed minus 2 times 2 squared plus 2 I. And that's 8 minus 8 plus 2, so that's 2i. Now I'm going to actually look at whether that's what they asked for or whether they've asked for a speed. And it's asked for a speed, so that means the speed, that's the velocity I've given here. So the speed is the magnitude of velocity, which in this case is 2. Don't need to use Pythagoras because it's just going 2 with no j component at all. Okay. Not too bad either. Question 2. Let's have a look at question 3. It's a centres of mass question. One day Edexcel will write a mechanics paper without a centres of mass question, but they certainly haven't done yet. They like them. Students really do. This is basically, I'm going to deal with this as a composite shape. I think with the triangle taken away. Yeah, so we want to work out some areas because it's told us it's uniform. So if we work out the areas, then we can have work out the ratios of masses. So I'm going to work out the area of triangle ABC. That equals the half times the base, which is 12a, times by the height, which is 9a. So that's 6a times 9, which is 54a squared. The area of triangle, the triangle bit that's cut out, is FED. And that equals to half times the base, which is 8a, times by the height, which is 6a. So that's 24a squared. So obviously the shape of the actual shape of this, the actual lamina we've got, is the difference of those two. So the ratio of masses is 24a squared, and the difference of the 54 and the other, and the 24a squared is 30a squared, and the composite shape 54a squared. Well, composite, the actual unknown is this one, but we'll deal with that. I always tend to make it so that almost regard this one as the combined mass at the end here and avoid negatives in my equation because I don't know, it just seems to make more sense. I'm going to break down the ratio, but that's enough to get the method marks really. But obviously the a squared going to cancel, so that ratio is now, I can divide all that by 6 and I get 4, 5 and 9 is my ratios. Okay, now the distances from the base from what's it asking for actually? It's asking for find in terms of A the distance of the lamina from AC. So distance from AC. For the 4A, that is actually the triangle here. That's represented by the triangle. That's corresponded to my 24A squared, which was the area of the triangle. That would be a third of the way up here. So that would be 2A, because the distance, the height of that triangle is 6A there. So it would be 2A. Right, now the 30A squared is the composite shape, or the actual shape that I don't know the centre of mass of. So let's call that Y bar, say, because it's vertical. Doesn't really matter, but some people get a bit funny about that. So Y bar, because it's vertically upwards. And then the 54A squared, which would be the actual centre of mass were there to be a whole lamina like that, which is 9A up, so that would be a third up, so that would be 3A. Okay, and as I said, I think in when we were doing June 2015, I like to think of this as almost you're starting off with a shape with an unknown centre of mass here. We're then adding on, almost like filling the hole here. I kind of seem to have reversed the order, but it doesn't matter. With a lamina here, which we know the centre of mass would be 2A. And then we would combine that to get the whole triangle, which would have a known centre of mass of 3A. Anyway, so we've got 4 times 2A. We can now multiply this all out, plus 5Y bar is 9 times 3A. So that's 8A plus 5Y bar is equal to 27A. So 5Y bar equals 19A. So Y bar is equal to 19 over 5A. So that's our answer for part A. Okay, now I'm going to now we're going to maybe redraw that diagram. Oh no, we can use the one up there. Let's do that. We're told that it's suspended from A and hangs in equilibrium. Find to the nearest degree the size of the angle AB makes with a vertical. So I'm going to draw in the vertical. Well, let's just draw in my centre of mass. Do not be concerned that my centre of mass is not at anywhere where there is actually, it's in the whole part of the lamina, it's in the bit where there is no actual lamina isn't there, it's in the whole bit. That can happen, so don't worry about that. The centre of mass is there where this is 19 over 5A. And we're going to draw the vertical line from A, and without having to try and draw a diagram with it rotated. So I'm just going to put in the vertical line now. Okay, so there's the vertical line. So we've saved having to draw it out. Now let's just mark on the angle. This angle we can work out easy enough using our centre of mass. Let's call that angle theta, say. And let's call the required angle that that's the required angle we have, alpha. If we work out theta, we can use the centre of mass there. We can also work out alpha, because you'll notice you can work out the whole angle. Let's do that bit first, in fact, because we've got a triangle there, a right angle triangle. So the whole angle, let's just change colour. Let's call it tan. The whole angle, which is alpha plus theta, is equal to the opposite side, which is 9A, over the adjacent side, which is 4A. So alpha that's 9, which is 9 over 4. So alpha plus theta, the whole of the angle that I've marked there, that whole angle there, is going to be the inverse tan, or the arctan of that. So that equals to 66 degrees. Oh God, it looks like I failed again. The length from there to there, of course, is 6a. And the length from there to there is 9a. So let's get it right. It's annoying. Okay, so that's over 6a. So that's 9 over 6. So the whole of that angle, I knew the 66 wasn't right. Okay. So the whole of that angle is equal to 56 degrees. And a whole load of other stuff. So now let's just work out the angle theta. Let's rub that stuff out now. We know that this length here is 19 over 5a, or 3.8a. And we know that the length here, we'll get it right this time, is equal to 6a. So we can say that tangent of theta is equal to 3.8a over 6a, 3.8 over 6. So that gives us theta is the inverse tan of that. Which is 32.34 and a whole lot of other stuff, because I don't want to have round inaccuracies in my inaccuracies, so I've stored them in my calculator. So the required angle alpha is equal to the difference between these two, the 56.3 blah blah blah, take away the 32.34 blah blah, and that equals to 23.96. But it does ask for the nearest whole number. I would be rounding to three significant figures, 23.0 normally, or to 20, but it asks for to the nearest degree here. So we will round that to 24 degrees. Okay, another fiddly sentence and maths question, but by far nowhere near the worst. Okay, let's have a look at question 4. Okay, it's another power question. This time we've got a truck carrying a trailer, and I think it's up a hill somewhere, up a straight road, which is inclined to an angle alpha, and we know alpha again, sine alpha equals 1 over 20. They're connected by some light rope T there. We're given the masses and therefore the weights of the truck. Truck is 1,800 G. The trailer is 800 G. Let's mark on the angle alpha on my diagram. And we've got some resistances. 300, the resistance of the truck and trailer from non-gravitational forces are modelled as constant. So this one is 300. And this one here is 200. And we're told the rate it's working in kilowatts. so we can use P equals FV to work out the driving force, because I've missed that out. It's not going to go up anything like that. So we've got the driving force. We can work out in terms of the velocity, because we want to work out the velocity, so we can connect the two. We can say that 40,000 is equal to force times velocity. So we're going to use that in a moment, and we can therefore put now look at F equals MA. I'm going to do it to the whole system. For years I insisted that the students would always consider the two particles separately and then eliminate T. Then I realised that I was being silly. Sometimes it's just quicker to look at the whole thing. And when I look at this whole system here, T is not going to be in my equation. So we've just got F going upwards. And we've got the components of the weights going downwards. So that's 1,800 G sine alpha minus 800 G sine alpha minus 300 minus 200. Now I've just realised that F equals M. I'm basically resolving. Acceleration is 0 here. So I'm resolving parallel to the slope, so that's going to be equal to 0. Okay, so I could have done that a bit easier by just saying F is equal to all of these added together, but never mind. Sometimes it just happens and you start on it and you realise you could have presented it a bit nicer. But anyway, never mind. That's at least correct. Let's just work through with this. Okay, old habits die hard. As I say, I'm not going to use a calculator. We've got F is equal to, these two combined are 2,600 G for a start. So that's 2,600 times by 9.8 times by 1 over 20, because that's sine alpha, minus 500. Okay, so the two cancel, so that F is equal to 130 times G, or it should have been plus 500, of course, plus 500. I've gone back to G there. Anyway, so I'm going to put that back into my value for F back into there. So I've got 40,000 is equal to 130 G plus 500. There's a V there. Now, V is obviously therefore equal to 40,000 over 130 G plus 500. So that equals 22.5 meters per second. Okay, and then the next bit it's saying that as the truck is moving up the road, the rope breaks. Find the acceleration, because what's going to happen now is that we've now got the truck without a tension going back, with just a 300 Newton force here, with the F that we had from before, same F at that instance. So we've got F. So the F is the same from before, and we've got the weight, which is 1800 G, inclined at alpha. It's now going to be accelerating. Okay, so at some acceleration A. So we can just work out, apply F equals ma. Up the slope. We have the driving force from before, let's just write F for now, minus the component of the weight, 1800 G sine alpha, take away the 300, is equal to 1800A, because the mass obviously of this is 1800. So we know the F, that's 130G plus 500, minus the 1800G sine alpha, so that's 1800G times 1/20, minus 300 is equal to 1800A. So that gives us 1000, all this lot works out to be 592. So that's 1800A equals 592. So A is 592 over 800, 1800. Let's give two significant figures for it. A is 0.33 meters per second. It's 0.328 reoccurring actually, but 0.33. Again, it won't accept the fraction 74 over 25 over 225. Would not, even though you might think that's a nicer answer. They would expect two significant figures, so it's either 0.33 or 0.329 is the two acceptable answers there. Okay, so that's the first 4 questions of this paper done, and we'll do the other 4 questions in the next part.